morning, students. Today we will discuss capacitance of a parallel plate capacitor with a conducting slab. In last video, we discussed about the dielectric. So today we will talk about the conducting slab. And already we know that in a conductor, the electric field is zero. So today we are going to talk about capacitance of a parallel plate capacitor in conducting medium. Okay, so today we are going to discuss about this. This is another important derivation. Already we have discussed about parallel plate in dielectric. So to start again with this, what we do, we consider a parallel plate capacitor like this. We have capacitor plates, one with the positive charge on it, another is the negative charge on it. We have plus Q on it, we have minus Q, and there is a conducting slab. And we all know that in a conductor the electric field is zero. We have already explained it. T is the thickness of the slab, D is the distance between the plates. So we know, and sigma is what? Charge per unit area. What is T? It is thickness of conducting slab, conducting medium. Okay, and D is distance between plates. Distance between plates. Okay, A is area of the plates. Area of plates. And we know that the external field here E naught is what? Already sigma by epsilon naught. So we are going to talk about the conducting medium. Simple. We know that as Q is equal to what? CV. C is the capacitance. So simply in place of Q can we write sigma A, yet sigma A will be CV. What is the potential difference? Last class also I told you that the potential difference is very important, and it is electric field into distance. So I think E naught, and E naught exists in only D minus T. So distance is D minus T, because inside the electric field is zero. Only it remains in D minus T. So this is potential difference. We will put it here, and C E naught D minus T. So ultimately sigma A, C, in place of E naught, we know that we will put sigma by epsilon naught, D minus T, sigma cancels out, and it will be epsilon naught A, what? C, D minus T, and finally C is what? Epsilon naught A, D minus T. So this is the expression of the capacitance in what? In conducting medium. This is the expression, and this was the potential difference across the plate. So even we can say that from here also C is what? C is less than C naught. C naught was in air medium. What was that? Epsilon naught A by D. So C is here again less than C naught. What is D? Distance between the plate. What is T? Thickness. So this is the concept for the conducting medium. Very easy. And you know that in this only, if I say T is equal to D, so T is equal to D means it is completely filled by the what? The conductor. If T is equal to D, do you know what will happen? C will be epsilon naught A by what? 0. C will become what? Infinite. So it is infinite if it is filled by what? The conducting medium. So this is also a concept when it is filled by conducting medium. So this is the case for the conductor. Now I have two very important concepts and the questions related with the capacitor, and these are that a parallel plate capacitor is charged by a battery. It is charged by a battery. Okay, which is then disconnected. Now after that it is disconnected. So, and after disconnecting, a dielectric slab is what? Filled in it, in between the plates. You have filled it in between the plates of capacitor. Then explain changes occur in the values. There are some changes occur in the values of what? First, charge. Second, what? Electric field. Third, potential difference. Fourth is capacitance. And fifth is what? Energy. Charge, electric field, potential. 5 things are given and you have to find out what will be the. So very simple. You know that I will make the 2 things here. One is that the capacitor was connected with the battery. Okay. And this was a battery. And then another was that the capacitor was disconnected and was filled by what? Dielectric. Got it? Say this is the potential difference. So initially it is in air medium. It is in air medium and now it is in dielectric. Okay. Now if I ask you what are the charge is say initially Q0. Q0 is what? C0, V0. What is electric field? Electric field is E0. V0 by what? D. Electric field is V by D. If I ask you what is the potential? Potential is V0. Okay. Potential is V0. What is about the capacitance? It is already C0. And what is energy? Energy is say half C0 V0 square. So what will be the changes here? You see here one by one. First is the charge. When we talk about the charge, we have to find out the charge. Now charge will be simply what? Charge will remain same. Charge is what? Q will be Q0. Okay. Then we talk about the electric field. Electric field, what happens to electric field? Now I think all of you know because it is of dielectric K. E will be what? E0 by K. Already we have explained it in earlier classes. So electric field, it what? Decreases. Then we talk about what? Potential difference. V, potential difference. So potential difference, can you tell me what should be the potential difference? We know that V is what? Electric field into distance. So if I write E, E0, D by K. So ultimately potential difference will be V0 by K. So it also decreases. Are you getting it? Because V0 is E0 into D. So ED, because here electric field will be what? ED. So this will. And then we talk about what? Potential difference, electric field, we have charge, electrical potential, and then capacitance. I think all of you know capacitance C will be Kc0. This also we have already done. It becomes K times of C0. And then at the last we talk about what? Energy, potential energy, and energy of the capacitor will be what? Say U. U will be what? Half CV square. Okay. So if I put here half, in place of C what I will put Kc0, and in place of V I will put V0 by K whole square. Do you know what I get? I will get what? K times of half C0 V0 square, and in denominator there will be single K. So can I write U0 by K? So energy also what? Decreases. So this is very important case. What happens to the charge? It remains same. What happens to the electric field? It decreases. What happens to potential difference? It decreases. Capacitance, what? Capacitance increases. We know that capacitance is K times, but energy, you know that it decreases. So this is the case for what? The when the battery is what? Disconnected. But the same question if I ask you when battery is disconnected, it can be in this way also. So if I ask you that battery is what? First is connected, now it remains connected. We are not disconnecting it. So that means, again we can see the case that this was the case when the battery remains what? Connected. So battery is connected in this case. So this is filled with dielectric. So again what we know that we have capacitance C naught, we have charge Q naught, we have potential difference V naught, we have electric field E naught, we have energy U naught. It is in air medium. Okay, now we have to calculate it in what? Dielectric medium. So dielectric medium will be what? If you see here, the main thing is that capacitance again becomes Kc naught. This is capacitance. So capacitance will what? It is going to increase. Capacitance is K times of C naught here. So it increases here. Then we talk about the charge. Now if I say what is the potential here? Here potential to charge is what? Here it will be CV. Now if I, what is C? Kc naught. But do you know V is V naught only? So V remains V naught. So this times K times of Q naught. The charge also increases. It is K times of Q naught. Now talk about the potential difference. V naught is here, V naught is here. So V will remain V naught because battery is connected. Battery is not disconnected. So it remains same. So the potential that remains same. V equal to V naught. And what about electric field? Electric field is V by D. And when V is V naught by D, it again remains same. So electric field also remains same. See the changes because we know that E naught is what? V naught by D. So it is the same because battery is connected. And now the last thing is about the energy. Energy will be what? Half CV square here. So half in place of C you will write Kc naught. And V is same. So V naught is square. So can you tell me what is K times of U naught? So energy increases. So these are the changes when battery remains connected. You are not changing the battery. So main thing is that the potential difference is same. Capacitance will be Kc naught. Charge you see here it becomes K times of Q naught. Potential difference is same. Electric field is same. But what happens? The energy is what? K times U naught. So there are two cases. One is battery connected and another is what? Battery disconnected. So this is the content of the chapter. Now we'll discuss some questions based on this. And I want to just explain you one question that how we find out the charge and potential difference, charge and potential difference in capacitor, potential difference in capacitors. Say I will give you an example, charge and potential difference, how we find it, how to calculate. Say there is a, like this, there are three capacitors given here, okay, and say one is of 4 microfarad, this is of 2 microfarad, okay, and this is of 3 microfarad, and there is a battery of say 12 volt. Very simple. Now the question will be how we are going. So the question is find charge and potential difference in each plate, in each capacitor, This is very important question. Like in resistances, we find current and voltage in every resistance, same here. So do you know what we'll do in this case? We will first find out the net capacitance. So this is C1, this is C2, C3. So what will be the net capacitance? C1 and C2 are in parallel. So C12 will be 4 plus 2. It will be 6 microfarad. And then with the series with this, so 1 upon C will be 1 upon C3 plus 1 upon C12. So 1 upon 3 plus 1 upon 6. Okay. So it becomes what? 3. So reciprocated. Ultimately C is what? 2 microfarad. The net capacitance is 2 microfarad. Okay. Now what is the net charge? First we will calculate the net charge. Remember net capacitance, after that net charge, what it is? Q equal to CB. What is potential difference? 12. What is C2? So 2 into 12. It is 24 microcoulomb is the net charge. That we have calculated. Net charge is also. Now remember one thing, that the charge in the series remains same. We have explained this in series and parallel. So which one is in series with this battery? It is C3. So do you know what will be Q3? Q3 will be 24 microcoulomb. Got it or not? Why Q3 is 24 microcoulomb? Because it is in series. Can you find out V3 in this? Potential difference in Q3, yes, V3. What is the potential difference? And it is Q by C. So Q by C3, that is 24 by 3. It will be what? 8 volt. So 24 by 3, that is 24 microcoulomb by 3. So micro will cut out, it will be 8 volt. That means it is 8 volt going in this. Got it or not? Out of 12, 8 has gone in what? C3. What is the remaining one? Remaining voltage is what? 4 volt. Out of 12, 8 is here, 4 will go here. So can you tell me what will be the voltage in C1? Yes, it is simply what? 4 volt. In parallel voltage are same. So it will be 4 volt. What will be V2? Yes, it will be 4 volt because parallel voltage are same. Can you find out the charges? Yes, 4, 4 just 16. So Q2, Q1 will be 16 microcoulomb. And what will be Q2? So Q2 will be what? 4 2 ja 8. So 8 microcoulomb. In this way we got all the charges in the capacitors and potential. Again repeating, first you find out the net capacitance, then you find out the net charge, then you check which capacitor is in series, which one? C3. So it will take same charge. In series charge same is same. Then you find out its potential difference. Very simple. When you know the charge, you will find out 24 by 3. It will be 8. And then the 8 has gone here. Remaining will be what? Out of 12 minus 8 is 4. Then 4 will go on this. Both are in parallel. So both will have same potential. And then what will be the charge? 4 4 just 16 and 4 2 just 8. So this is how we are going to find out charge. Now we have another very important question here. Obtain the equivalent capacitance of the network in the figure for a 300 volt supply. Determine the charge and voltage across each capacitor. So we have given 4 capacitors, C1, C2, C3, C4. One is of 100, other is of 200 picofarad and 100 picofarad and 300 volt. Remember, 1 picofarad is 10 to the power minus 12 farad. So these are the combination given and you have to find out charge and potential. Again, that question, charge and voltage, how we calculate. So first we will find out the net capacitance. Do you know C2 and C3 will always go through the closed circuit. C2 and C3 are in what? C2 and C3 are in series. So directly I am going to write it 1 by 200 plus 1 by 200. So calculate it, it will become what? 100. So they are in series. I am going to write it 1 by C23, 1 by C2 plus 1 by C3. So 1 by 200 plus 1 by 200. Okay, it becomes what? 2 by 200, and simply it is 1 by 100. So reciprocated, it comes 100 picofarad. Okay, now it is in parallel with C1. So parallel with C1. Got it? So C dash will be C23 plus C1, and I can write it 100 plus 100. It is 200 picofarad. And finally, you know that it will be in series with C4. Why? Because battery is in this side. Remember, most of the students, they do a mistake. They take all in parallel. No, this is in series with C3. So finally 1 upon C will be 1 upon C dash plus 1 upon C4. So 1 upon 200 plus 1 upon 100. And you solve it, it becomes 3 by 200 and reciprocated to 200 by 3. What? Picofarad is the equivalent capacitance. Got it or not? Why? Because C dash and C4 are in what? Series. So this is the net capacitance. And then can you find out the net charge? What we did? How do you know? We calculated net charge. What is net charge? CB. What is C? 200 by 3 and it is 300. Okay. So we calculate it. So 2 into 10 to 100 into 100, and you know it is in pico, so 10 to the power what? Minus. So what is the charge? 2 into 10 to the power minus 8 coulomb. This is net charge. Now can you tell me which is in series with this battery? C4. So C4 will have the same charge. Q4 will be what? Q, because it is in series. So Q4 is 2 into 10 to the power minus 8 coulomb. Can you find out its potential difference? Yes, V4 can be written as Q by what? C4. So 2 into 10 to the power minus 8 upon 100 into 10 to the power what? Minus 12. So solve it, you will get 200 volt. So do you know, out of 300, 200 volt is supplied here. Got it or not? So remaining 100 goes on this side. So 100 will go on this side. So if 100 goes on this side, it will have 50 volt and 50 volt, and it will have 100 volt. Why? Because both are in series, potential difference equally divide, and it in parallel. So if I ask you what will be V2, V2 will be 50 volt. What will be, can you find out Q2? What? C2 into V2. So what is C2? It is 200 into what? 50 into 10 to the power minus 12. So calculate it. It becomes what? 2 5s are 10, and then it is 10 to the power minus 8 coulomb. This is for V2, and same is for what? V3. V3 is 50 volt, and same charge will come. Why? Because they are in series. And then C1. For C1, we can calculate that for C1, it will be what? What is the voltage? Voltage is 100 volt. What is Q1? C1 into what? What? V1. So 100 into 100 picofarad and 10 to the power minus 12. So directly 10 to the power minus 8 coulomb. So in this way, we get all the potential differences. For it, we got 200 volt, charge is this. For the C2, we got 50 volt and charge is this. For V3, we got what? 50 volt and charge will remain same, because potential difference divide. And for C1, voltage is 100 volt and charge will be C1 V1. So it is the answer. So in this way, we calculated first net capacitance, then net capacitance, then net charge, then we check which is in series. This is in series, we get the same charge. Then we got 200 volt. Out of 300, 200 goes here, 100 goes on that side. So 50, 50 divides, and it will be 100. Then we calculated for all the 4 capacitors. So this is very important question, and it is in NCERT. And there is another question which I am going to discuss is this. 4 microfarad capacitor is charged by 200 volt supply. It is then disconnected from the supply and is connected to another uncharged. Will there be some energy loss? Yes, we have discussed this energy loss, and we will find out the energy loss in this. How much is energy is lost? And remember, energy is lost in the form of heat and electromagnetic radiation. Remember, this can also be a question. Heat always loses in the form of this. So can we find out it? Yes. So what will be the initial energy if I ask you? So initial energy will be, you know, half CV square. So what is capacitance? I think 4 microfarad. 4 into 10 to the power minus 6. What is the supply? 200. So 200 square. Calculate it. It becomes 8, 2 square and 8 into 10 to the power minus 2 joule. So this is initial energy. Now do you know charge on 4 microfarad? So can we calculate charge on 4 microfarad? Yes, it will be what? CV. So 4 into 10 to the power minus 6 into what? 200. So can we calculate? Yes, 8 into 10 to the power minus 4. Now it is connected to another uncharged. So if it is connected to another uncharged, then do you know, you remember what will be the common potential? Total charge upon what? Total capacitance. You remember it? Yes. What is total charge? It will be Q1 plus Q2 upon C1 plus C2. But do you know the Q2 is 0 because it is uncharged, second capacitor. So what is Q1? It is 8 into 10 to the power minus 4. And what is C1 plus C2? This is 2 and this is 4. Then that means 4 plus 2 into 10 to the power what? Minus 6. So if you calculate it becomes 400 by 3 volt. So you got this common potential. And then you can find out the final energy. And final energy will be, you remember, it will be half. Net capacitance is C. C is 4 plus 2 into 10 to the power minus 6, and V square. V is 400 by 3 square. So you calculate it, it becomes 16 by 3 into 10 to the power minus 2 joule. That comes 5.33 into 10 to the power minus 2. This will be final energy. And is there energy loss? Yes, this energy is rated. So energy loss, we have already done this concept, will be U initial minus U final. That is 8 into 10 to the power minus 2 minus 5.33 into 10 to the power minus 2. So if you calculate it, it comes 2.67 into 10 to the power minus 2 joule. So this is the answer. How you calculated initial energy, then you calculated the common potential total charge. In second one, it is uncharged, so Q2 will be 0. And then final energy will be net C into V square, and you got it, the difference. So this is the question related with it. And then there is another question. It's a very important question. If you see, it has 3 parts. What is the question? If you see, it is written that a parallel plate capacitor X and Y have same area, same separation. They are identical. X has air and Y has what? Dielectric medium. So it has a dielectric medium. And then calculate capacitance of each capacitor, because net capacitance is given, and calculate potential difference in both X and Y different, and then ratio of electrostatic energy. So first you have to calculate what? Capacitance. So net capacitance is given. What is that? 4 microfarad. Say this is Cx for this, and Cx will be considered, say it is C. And what is Cy? Remember K times C or C naught, K times C naught. So K times C naught, what is K? It is epsilon R. That is 4, so 4 C naught. And you know what will be C? C is the net capacitance. Both are in series. Can I write 1 upon C equal to 1 upon Cx plus 1 upon Cy, because both are in series? Can I write directly Cx Cy upon Cx plus Cy? So what is Cx? C naught. What is this? 4 C naught. And this will be C naught plus 4 C naught. So I think it becomes, if you calculate it, it becomes 4 by 5 C naught. So 4 by 5 C naught it comes. Got it? So it is equal to what? 4. So 4 will be 4 by 5 C naught. So C naught comes what? 5 microfarad. And that means Cx is 5 microfarad. And what will be Cy? 4 times C naught. So it will be 20 microfarad. The first answer comes. This is the capacitance. And then potential difference. What will be the potential difference between the plates? Do you know what is the net charge? It is Cb. Net charge is Cb. So net capacitance 4 into 15 will be 60 microcoulomb. So 60 microcoulomb will go in series, you all know. So what will be potential? Vx will be Q by Cx. What is Q? 60. What is Cx? 5. So it becomes what? 12 volt. What is Vy? I think you know, Q by Cy. Why? Because charge remains same. So 60 by what? You know that this is 20 and this will be 3 volt. So you got the potential difference also. You got the capacitance. And can you find out the energy ratio? Yes. E1 is what? You know that E1 is half CV what? X square. And E2 will be what? Cx. And half Cy Vy square. And then you take the ratio. If you take the ratio E1 by E2, do you know, you calculate it, it is half C, Cxc, and in place of Vx it is 12 square, and then half in place of Cy, it is 4 times C, and it is, what is the potential difference? 3 square. So you calculate it, do you know the ratio you get is what? 4 ratio 1. You calculate it, you will get 4 ratio 1, because 12 square 144, and then it is 9 4 the 36, and then you calculate 4 ratio 1. So these are the three answers. The capacitances Cx and Cy you calculated how, because net capacitance was given. This is C naught. It will be K times of C naught. Then you calculated it from here. You calculated it, and then the charge net will be same. So potential you can get like this, 12 volt and 3 volt, Q by Cx, Q by charge is same. So 12 and 3, and then energy ratio formula half Cx Vx square, and then we know that it will be this. So this will be the what ratio. So in this way, these are the basic questions. The content is finished. We'll discuss numerical in next session. Thank you, and regularly watch my videos.